Algebra 2. In this video, we'll be going over example 3 shown on the screen. We'll also be going through example 4, which is right here. Okay, so if you need to look at the timestamps in the Google Slides to see where you would like to start the video to go over it, feel free to go and do that. So let's go ahead and get started. So the first thing we're going to do is for part D, they want us on the table to label where the function is increasing or decreasing. So we're going to start over here. So from negative 11.5 to 6, that's a big increase. And then from 6 to 4.5, that's a decrease. 4.5 to 2, that's another decrease. And then from 2 to 4.5, that's an increase, another increase. And then I actually do a big drop right here. So on my table, we're going to write an increase right here. And then we're decreasing between these 2 points, so decrease. We're increasing right here from 2 to 6, and we're decreasing here. Okay, so I've labeled that on my table. That is all done. Okay, so now let's identify what the end behavior is going to be. So one of the ways that we can do this is by looking at our table and doing it just like how we did it in example 1 over here, which is look at how the graph is behaving, or look at how the table's behaving as we read it from left to right for the right part of the graph, and then from right to left for the left part of the graph. But since we've got an equation, let's use this to our advantage. So let's find the degree of this polynomial. So the degree is 4. It's the highest exponent that I see. So I know that my graph is going to either have 2 arrows pointing in the same direction going up, or 2 arrows in the same direction pointing down, because that's what even degree polynomials look like. The next thing I want to do is identify what my leading coefficient is. Coefficient. Okay, so the number in front of the term with the highest degree is negative 0.5. So since that number is negative, the correct sketch, so to speak, would actually be this one. So my graph would have 2 arrows on both sides pointing down because of that negative leading coefficient in front. If it were positive, it would be this one, but since it's not, it's the one that we circled. Okay, so now let's write our end behavior. So our end behavior is going to be as x goes to positive infinity, my y's are going to be decreasing. So as x goes to positive infinity, y goes to negative infinity. And as x goes to negative infinity, my y's are going to also be going towards negative infinity. Okay, and now we need to identify between which 2 x values are our turning points. So we've actually got 3. So I see that between -3 and -1, that's a turning point. I also see between -1 and 1. And then our last one is going to be between 1 and 3. Those are where our turning points are occurring. So we can go ahead and write that out. So between x equals -3 and x equals -1, between x equals -1 and between x equals 1, between x equals 1 and x equals 3. So we've got 3 turning points here. Okay, let's go ahead and wrap this one up and go ahead